Guys, it's your boy Kev the Science Kid, and today I'm going to be teaching you about calorimetry, and more specifically how to solve for delta H over mole when a hot metal is added to water. So first and foremost, the definition of calorimetry is the science or act of measuring changes in state variables of a body for the purpose of deriving the heat transfer associated with changes of its state. So we have a diagram of a coffee cup calorimeter, and to make one of these you need a stirring rod, a thermometer, a lid, water, and metal, and a coffee cup. And the metal reacts with the water after you stir it with the stirring rod, and it will raise the temperature or decrease the temperature, which is what you need the thermometer for. So, like I said before, we're going to be solving for delta H over mole when a hot metal is added to water. So, an example problem is 2 grams of CH4O is dissolved in 100 milliliters of water at 20 degrees Celsius. The temperature of the water then rises to 25.5 degrees Celsius, and then you must calculate delta H in joules. So step 1 to solve this problem is you need to calculate the heat released from the reaction in joules. And you do that by using the equation Q equals mass times specific heat times temperature change. And to find the temperature change, you subtract the initial temperature from the final temperature. So our initial temperature was 20 degrees Celsius, and we subtract that from the final temperature, which was 25.5 degrees Celsius. And we end up with the final answer of 5.5 degrees Celsius. And that's the temperature change that we use in the equation. And the specific heat is given. The specific heat of water is 4.184 joules over grams times Kelvin. The mass is also given, and it is 100 grams, as there's 100 milliliters of the water. So that leaves our equation with to come up to be Q equals 100 grams times 4.184 joules over grams times Kelvin times 5.5 degrees Celsius. And if you plug that into a calculator, or if you do on paper, either way you'll get Q equals 2301.2 joules. For step 2 to solve this problem, you find the moles of the given solute, which is CH4O. That's the given solute. And to do this, you use a mole equation, which is mass over molar mass. So the moles of CH4O equal 2 grams over 32.0419 grams over moles. And the 2 grams are the mass, and the 32.0419 grams over moles are the molar mass of CH4O. And if you plug this in the calculator, if you do it on paper, either way you get the same answer of 0.06 moles rounded. So step 3, you calculate the enthalpy change, also known as delta H, in kilojoules moles to the power of -1 of the solute, which is CH4O. Delta H, the equation for this is delta H equals -Q over 1000 divided by solute in moles. And you divide by 1000 because you're trying to convert it into kilojoules. So delta H equals -2301.2 joules divided by 1000 divided by 0.06 moles. And you end up getting delta H is approximately -38.4 kilojoule moles to the power of -1. The reason why delta H is negative is because it is exothermic. And exothermic is the reaction or process accompanied by the release of heat. And when you release heat, it equals an increase in temperature. And that is how you solve for delta H over mole when a hot metal is added to water.